We want to start by modeling the canal. So we're going to click New in the first page of Revit, and to find the appropriate template for this matter, I can go to the English folder where we have the metric items, and then we select the mechanical default metric file and open it. And from these two options, we're going to select Project and then click OK. As we've mentioned previously, we have two important groups, mechanical and plumbing. The views that exist as the subgroups for the mechanical, here we can see all of the drawn canals. But if we look at the subgroups for plumbing, we can't see any of those canals, because this is how these settings have been adjusted, and we will become familiar with how to adjust those settings later on. Now, if we go to the mechanical group and choose one of the elevations, and by those we mean the east, north, south, and west views. For example, we're selecting the east, so we can see its view, and as you can see, we have two different levels here, level 1 and level 2. One at the height 0, and the other 4,000 millimeters. So now we want to draw some canals in the level 1, which would be somewhere around here. And for now, we're not going to pay attention with the coordination of our canal with all the other objects. We just want to draw some spontaneous canals so that we become familiar with this command. And then we're going to take the things that we drew to a sample project and check it out over there. So we go to One Mechanic Plan so that we can draw the canal onto the first level. We go to the Systems tab and click on the Duct command, or we could press the D and T keys from the keyboard, which is the shortcut for it. So to draw the duct, we can click on an empty space on our page. We can also zoom in a little bit, and we're going to give it a little bit of angle in the second click, and now the third one, and the fourth click. As you can see, this command is continuous, and after each click that we apply, the necessary fitting duct, or actually the curve, would also be created between two straight ducts. So this is how we draw a canal. Now let's go check to see what its cross-section looks like, and what are the measurements, and in which level are we drawing, and settings like that. Now to cancel the duct command, we can press the escape key on our keyboard twice. Let me click some ducts again. Click, click, click. You see it's drawing ducts for me continuously. If we press the escape key once, the continuation would stop, but the duct command would still be activated. So we can go to a different place and start drawing ducts again. But if I want to cancel the command completely, I can press the escape key, the one that you see on your keyboard. We can press it twice. You see the command has been cancelled. Or we can do something else. We can go to the ribbon and then click on Modify, and then the command would be cancelled. Another thing that we can do is that we can right-click and click on Cancel. This cancel option would actually stop the continuation. It does the same thing as pressing the escape key once. But if we right-click and click on Cancel again, the entire command would be cancelled. So we had three different options: using the escape key, using Modify, and right-click and cancel. Now I want to delete all of these ducts that I just drew so that we can talk about some other things. We can select the drawn items by clicking and dragging. If we click on the left side and then drag our mouse, each item that would go completely under that box would be selected. But if only a small part of it is included in that box, all of it wouldn't be selected. We have to hold a complete item. So this was for clicking from the left. But if we drag from the right side, even if just a small part of an item is included, all of it would be selected. You can see it's been highlighted. We're going to go down this fitting, this duct, and this one. So don't forget about these two small points when trying to select your items. If you're clicking from the left side, you have to include the entire item. But if you're clicking from the right, even the small parts would take the whole items. So after we select our items, we can go here and click on delete, or we could use the shortcut DE, or we could just press the delete key from our keyboard. So you have 3 different ways to delete your drawn items. Alright, so again we go to the Systems tab and click on the Duct command. But before we start drawing our canal, first we have to clarify what we want our cross-section to look like, and how do we want the fitting ducts to look like when they go between 2 straight ducts. To do that, we go to the Properties window and click on this drawer here so that we would have this list. We have 3 different parts: oval duct, rectangular duct, and the round duct. Oval is for drawing ducts with oval cross sections, and rectangular is for drawing ducts with the cross section rectangular, and round is for drawing ducts with circular cross sections. Now we have some different subgroups for each of these groups, which are actually called different types. For example, for the rectangular duct, we have 4 different types, which are indicating the elbows or the connections. Now let's go see what they look like. For example, I can go select the radius, elbows, tabs. Let's click on it. So the type of our cross-section is rectangular, and its cross-section is radius, elbows, tabs. Now the next thing that we should do is that we have to enter the dimensions of our cross-sections. We can do that by either going up here to the options bar, or we could go to the properties window and this section right here. And as you can see, this dimensions option is so practical that Revit has separated it and put it here in the options bar so that I would have quicker access. So we're going to click on it and we have width. And for example, we're going to enter number 1000. And remember that our unit is millimeter right here. Later I'm going to show you where you can check to see what your unit is. Okay, so I'm going to drag the mouse pointer out so that the number would be applied. And now I'm going to put it in height and click so that we can enter a number for the height of our duct. So we're going to type in 800 millimeters and drag the mouse pointer out again. So by now we have selected the type of our connections as well as the dimensions for our cross section. Now we have to decide that this duct that we are drawing, in which level would it be drawn compared to the level that we are already onto. To check which level we are on, we go to the Properties window, and right here, Reference Level, we can see it's level 1. This is actually the level in which the one mechanical view has been drawn on. So we go to the Options bar. Here the middle elevation would actually be the height of the center of our cross section compared to the surface of the level, and we have to determine that. In other words, the height of the center of the cross section compared to the reference level. It's 2,750 millimeters. But for example, we're going to enter 3,000 so that it would be drawn 3 meters high. Now we're going to click and zoom in a little and move the mouse and click again. For the continuation of the canal, we can determine the facing of the ducts by moving our pointer, as in we can give it an angle, and this angle could be from 0 to 90 degrees. And as for the height, we can either guess it using our eyes, or we could just enter the number that we want from our keyboard. I'm just going to enter the number without clicking anywhere. 5,000. Now I press enter, and as you can see, it just drew the duct for me. And now from the axis of the cross section up to this point, it's 5 meters long. Now again, to continue our work, we're gonna determine the angle by moving our mouse around. And I'm just gonna use the numbers that I see, 6 meters, and then click. Now we go to the right, and this way we can continue drawing our canal with the height 3 meters. Now let me press the escape key once so that the continuation would stop, but we still need the command to be activated. 1,800. And the duct command is still on. Now we want to add some branches to this piece of duct that we have drawn. We're gonna click and click again. Now we press the escape key once. So to draw branches, we can either click on this central line of the duct and then escape, or here on the outer edge of this side, we can click and press the escape key again, or we can go to this side and click again. It really makes no difference. No matter where I click, these branches would be drawn for me. So I'm gonna click escape again so that the duct command would be cancelled. And now drag the whole thing so that it would be selected, and then press delete. Remember to learn the duct shortcut right here. It's DT. You go to your keyboard and press the D and T keys. Now we want to know what this radius elbows tabs means. Let's draw a piece of duct. Click, click, and escape. This little connection right here, which is also called an elbow, it has a circular round shape. It's like a curve. We call this in Revit a radius elbow. So now you know why it's called like that. So now you know what this radius elbow is. So we're going to have this radius elbow wherever we need a connection. Now we want to draw a branch. Let's make our dimensions a little smaller. We're going to enter 500 and 500 again. Now we're going to go here, and we said it's no different if we click here or here or here. So I'm going to click and move the mouse around and click again and escape. So now this branch has been drawn. I think we could see it better if we view it in 3D. Let's go to the quick access toolbar and click on default 3D view so that we can view our drawing in 3D. Now we can hold the shift key and then click the scroller, and at the same time move this around so that I can rotate the drawing. Now I'm gonna roll the scroller upwards so that it would zoom in for me with the pointer as my center. Downwards is zoom out and upwards is zoom in. So we can see the type of our branch. You can see that its form is kind of like it's been stuffed into the duct. Or we could say that the branch looks direct. As in, from this height of the duct, a small part has been cut and this has gotten out from that part. We go to the View tab, and if we click on Tile Views, then these two tabs that you can see are open right next to each other, we would then be able to see them both in a single view. You know what tile means, right? So we click the Tile Views, and now my drawing area has been split into two, and in one part of it I can see the 3D view, and in the other I can see my plan. It's the floor plan that we drew. So for the connection type, as we said, we have this stuffed-like shape, or what we call a direct branch. In Revit, we call that a tap. What was the type of our duct when we click on it so that it would be selected? In the Properties window, it also tells me its type. It's radius, elbows, taps, meaning that if an elbow should be added for me, it would look like this. And if I am going to add a branch, it would be in tap. Again, I can go to the View tab and click on Tab View so that each window would occupy an entire page for it. And then I can see each view by going into its tab. In the Systems tab and the Duct command, we are going to open this drawer and select Radius, Elbows, Tees. We just want to see what other types of connections do we have. And now for the dimensions, like the one before, we put 1000 and 800. And can you see how it's showing me the direction by dash lines? It would be helpful if I need them while drawing. So I'm going to click and move the mouse horizontally and click again. And now drag it vertically. And as you can see, it's also showing me the direction by dash lines again. I'm going to click again and escape once. So this is that radius elbow. Now we want to add a branch. We're going to click and click again. And now escape. As you can see, it just created a triode. You can see that it has split my duct into two parts with a fitting right here. Now if I view this in 3D, it would look like this. The triode, which here we call a T, we can see that in this branch. So if we use the radius, elbows, taps, the branch would look like a tap. And if I use radius, elbows, tees, the branch would get a triode shape. Let's go to the other type. We have mitered, elbows, taps. We can guess what the taps part is. It's this direct branch that we just saw. But what's a mitered elbow? Let's go draw that so we can see. I'm going to click and select it. And we go to the area and the first click and the second click vertical. And then click again and press escape. So as you can see, this elbow that we just got, it has a corner. It has a 90-degree angle. We call this one a mitered elbow. So now we got radius elbow and mitered elbow. And now for our branches, we're going to enter 500 for the width. And with the height 500, click and click. And our branches are taps. Now the last connection type for the rectangular ducts is mitered elbows, tees. Now let me enter the previous dimensions, 1000 and 800, and click and click. Now click again and press escape once, and now the branch, click, click, and escape. So now we have radius elbows and mitered elbows. The branch type is taps, and on here we have tees. These are the 4 different types which we had under the rectangular duct group. We also have very similar types for both round and oval ducts as well, which we will practice some different types as well later on. And we will model them and see how we can draw them. You can see the radius and mitered elbows in this picture, and we can analyze them based on the airflow that goes through them. The air is coming in. In the radius elbow, it goes very well to this direction. And in the mitered elbow, because of the sharp angles that we have, the flow would slow down at these corners, which lowers the pressure of the air. So this is one of the cons of the mitered elbows. But what pros does it have that make it worth using? Let's go back to our Revit. And here in the area, first I'm going to go to the Wall command from the Architecture tab. and draw a piece of wall right here. Now let's say that we have a canal, which actually let me go draw this canal by radius elbows. Okay, now we go here. Actually, let me go a bit further, and here we go. Okay, so here's our canal. If we use the radius elbow, we can see that this corner of the wall is interfering with our elbow. Okay, now let's say that I don't have the permission, or I don't even have the enough space to move this canal around upwards or to the right so that I can fix this interference. So to solve this, what I can do is I go and use a mitered elbow. So I'm going to select that elbow from the Properties window and select the rectangular mitered elbow and replace that. So you can see that the problem's solved. So in case I have limited space, I can use the mitered elbow. But as we've also said before, this elbow lowers the pressure a little bit. And to solve that issue, some vanes can be included into the elbow. They are called turning vane, which helps the air flow a little easier. If you look here in this picture, you can see these little vanes installed into the elbow. And we can see the airflow by these blue dash lines. So this means that the airflow wouldn't get stuck here in these sharp corners. So the air would flow in this direction that you can see. Saying all of the points about drawing canals, let's talk a little bit about the drawing units for the canals. Now to adjust those units in the project, we can go to the Manage tab and then click on Project Units, or we could just use its shortcut, which is UN. Now in the window that pops up, here in the Discipline section, the items have been grouped. We have a common option, which includes some general parameters, things like the length unit. If I click on the box in front of it, another window would pop up for me where I can adjust those units over there. We're going to go to Units, which is on millimeter right now, and in rounding the number of decimals, and in the unit symbol, I can choose a symbol so that it would be shown as the unit. Okay, now we go here to the HVAC part, and then we find the duct size. Now, if I click right here, it tells me that my canals are being drawn with the unit millimeter, and they have no decimal places, and I also have no symbols. Now I'm going to change this to inches. It's possible that in some projects your units would need to be inch. And I'm going to have 2 decimal places, and for the unit symbol, I'm going to select in, which is short for inch. Now we're clicking OK. Now if I go to the Systems tab and click on the Duct command, in the options bar I can see that both the width and the heights are shown in inch. I can also see this IN, short for inch. Now I'm going to press the escape key to cancel the duct command. And now if I click on any of the ducts, I can see that their units have been converted to inch. The duct's dimensions were 1,800, and they've been multiplied by 25.4 and converted to inch. What I mean is that if I go here and divide 1,000 by 25.4, I will get the number 39.37. And the same thing for height as well. So now I know that the unit of the canals I drew was millimeter. If I press the UN shortcut again, and then go to HVAC and find the duct size and open it and change the unit back to millimeter. And I don't want no decimals, but I still want the millimeter symbol. And clicking OK and OK. Now if I press DT for the duct command, here I can see the symbol of the unit next to the number that I've entered.